Lesson 2.6, we're looking at applying proportional reasoning to solve problems. It starts on page 121. We are going to go ahead and look at page 122. So example 1, ratio of collectible cards Deshawn owns to cards Stephanie owns is 5:2. Stephanie has 36 cards. How will the ratio of Deshawn's cards to Stephanie's cards change if they both sell half their cards, and explain? Okay, so first of all, we have to figure out actually how many cards Deshawn has. So this is probably what I would have done with a slight modification. So I would have said the ratio is 5:2. 5:2, that's ratio of Deshawn to Stephanie. And then we know that Stephanie has 36 cards. And the question is, how many cards does Deshawn have? So we could set up a proportion like this. If you want to do a D for Deshawn there, you could, like we've done. And then looking for patterns. Remember, the pattern has to be multiplying or dividing for it to be equivalent fraction. So if you did 36 divided by 2, you would get 18. So just like the book shows here, going from 2 to 36 is multiplying by 18. And so to get an equivalent fraction, multiply the numerator by 18 also. So 5 times 18, and that would give you 90. So that, first of all, tells us that Deshawn has 90 cards. That's our first step in this problem. Once we know that Deshawn has 90 cards, now let the selling begin. Each of them sells half their cards. So half of 90 would give Deshawn 45 cards. Half of 36 would give Stephanie 18 cards. So the book shows this by table. This last part of the table, multiplying by half. Or you could say dividing by 2 to get that. And then the question is whether the ratio is changing, or how will the ratio change if they sold both sold half their cards. So 45 over 18, both of those we can reduce by 9. And that would be 5/2. So we started out with the ratio of 5/2. They sold half their cards. They still would have a ratio of 5/2. So actually the ratio did not change by selling half their cards. So the triad is a continuation of this problem. After selling half their card collections, after selling it, okay, Deshawn and Stephanie each buy 9 new cards. What is the ratio of the number of cards Deshawn has to the number Stephanie has? Alright, so after selling half, Deshawn has 45 cards, and Stephanie has 18 cards. So if they each buy 9 new cards, Deshawn had 45, now would have 54 cards. Stephanie had 18 cards. She would now have 27 cards. So this ratio of Deshawn to Stephanie then at this point, it would be 54/27. You might notice you can reduce both of those by 9, which would get us down to 6/3. And then both of those are divisible by 3, would get us to 2/1. So ratio there is 2/1. Remember, with a ratio, we want to have 2 numbers, so make sure you put it as 2/1, not just 2. And then the convince me asks, why did the ratio stay the same in the example but change in the try it? It basically is the same idea as when you guys try to find equivalent fractions. Equivalent fractions, if you multiply or divide your numerator and denominator by the same thing, you get an equivalent fraction, right? So like on example 1, you could say multiply by half or divide by 2. Okay, so just like if we have a fraction, like if you have 10 twelfths, for example, if I have 10 twelfths and I divide both of those by 2, I get 5/6, which is an equivalent fraction. Okay, the same is not true if we take a fraction and we just add or subtract a number from it. We can't just say, well, I've got 10 twelfths, I'm just going to add 4 to both of these, and now I've got 14 sixteenths. Okay, that does not give you an equivalent fraction, and that's why our ratio was not an equivalent ratio. It did not stay as a ratio of 5 to 2. It now changed to a ratio of 2 to 1. Example 2, Martin is 6 years old when his sister Cassandra is 3 years old. How old will Martin be when Cassandra is 6 years old? So basically, if we just focus on the table, Martin is 6, Cassandra is 3. So they just kept adding a year to their age each time. And then you can see when she was 6 that he would be 9. And I'm kind of focusing on just the table because really some of the stuff off to the side we don't necessarily have to do for this problem. Basically what they're pointing out is Martin's age got multiplied by 1.5. Cassandra's age doubled. It got multiplied by 2. And so basically, you know, we could look at, to start with, Martin compared to Cassandra. Martin was twice as old, but you know, 3 years later it's 9 to 6, so it's a 3 to 2 ratio instead of a 2 to 1. So instead of being double the age, Martin's now only 1.5 times as old as Cassandra. Okay, and that's something you guys might have experienced with siblings, where at one point you might have been twice as old as a sibling. Okay, and then it does not continue to be the case though. Example 3, a video streaming service charged Brian $143.84 for a full year of access. Brian thinks he was not charged the correct amount. What should Brian say when he calls customer service? Okay, so you can see from the picture, this was $8.99 a month. So $8.99 a month, that's like our unit rate or our slope. So we could say our equation would be $8.99, y equals $8.99x. And then we know a year is 12 months. So one way of doing that, we could substitute into the equation, or even without the equation, you guys would know, you could just do $8.99 times 12. That would be your cost for a year. So it should have been $107.88, and he actually got charged $143.84. So if you subtract, he got overcharged, looks like, by $35.96.
Well then.
Another way of doing that would be that you could have put in your equation $143.84 for the cost. They're multiplying, so if you divide by $8.99, you would get 16, and that shows actually that he was charged for 16 months instead of 12 months. And then he could just ask for 4 months. The next 4 months of not being charged would be another way that we could do that. If you look at the try it, a florist makes bouquets that include 50 white flowers and 7 red flowers. And the florist orders 1,050 white flowers and 140 red flowers. There would be leftover flowers. So how can the florist adjust the order so there will be no leftover flowers? All right, so basically we want to keep this ratio of 50 to 7. 50 white flowers for every 7 red flowers. So 2 different options. One option is let's keep the number of red and change the number of white, or we can do the opposite of that. So if you think about trying to find a pattern, for the white roses going from 50 to 1050. You know, what do we multiply to go from 50 to 1050? Might not be real easy to come up with that. For the red, might be a little bit easier going from 7 to 140. So I'm going to look at what would happen if we just keep our red flowers the same. If we keep that at 140. So going from 7 to 140, you know 7 times 2 is 14. So 7 times 20 would be 140. So if you take 50 times 20, if you work that out, that would be 1,000. So we could adjust the order if we haven't gotten these roses already. If we'd get 1,000 white roses instead of 1,050, so that would be, you know, I guess just to show our work here, 1,050 minus 1,000 is 50. So we could order 50 fewer white flowers. That would be one way to do this problem. Another option, like I said, would be to do it the other way around. So we have this ratio 50 to 7, white to red. So if we keep the white at 1,050, that would be multiplying by 21. If you take 1,050 divided by 50, you get 21. So 7 times 21 would be 147. So we were going to get 140 red flowers. If we get 147, that would be ordering 7 more red flowers. So a couple different options how we could get that to work.